Hello everyone and welcome to this week's Maritime Innovation Update. My name is Virab Gevorkyan and I will be your moderator today. Before we begin, a quick reminder about to please stay muted and turn off your videos because this session is being recorded. For any questions, you can write them in the chat or raise your hand at the end of the presentation. And now it's my great pleasure to introduce our speaker, Rachit Srivastava. Rachit has a master's degree in relation to port operations and logistics and has been with Fraunhofer CML for already 3 years, where his work focuses mainly on simulation studies for port terminals and terminal concepts in general. Today, he'll be giving us an interesting presentation about one of our latest IHATEC projects, the SimTwist, which is focusing on automated twistlock handling operations. So let's get started. Rachit, the floor is yours. Thank you.
Thank you, Virab. I hope I'm audible to everyone. So, my name is Rachit Srivastava, and today I'm going to present the topic SimTwist, a simulation study focusing on automated twistlock handling operations at terminals. Now, these are the topics that we are going to cover in today's presentation. So, we will directly jump onto the project details. SimTwist. The project basically focuses on studying available automated twistlock handling technologies and their impacts on automated terminal operations. And we are studying this through simulation experimentation. The project has already started from the beginning of this year, from 1st January 2025, and the duration is 2 years. That is, it's going to end by the end of December 2026. The project is sponsored to us by Bundesministerium für Digitales und Verkehr, BMDV, and the project partners are Eurogate Container Terminal Wilhelmshaven, which is also the industrial partner. And for the project work, there are 2 research partners. One is Fraunhofer Center for Maritime Logistics and Services, and the another is the Bremer Institute for Production and Logistics GmbH. Now, before diving deep into the automated twistlock handling operations, and so it's better we first understand what is a twistlock. So twistlock is a mechanical device which is used to connect stacked containers on top of each other, and these containers are basically situated on the upper deck of the vessel, as you can see it from the pictures. And handling of these twistlocks, that is removing of the twistlock and attaching of twistlocks to the containers corner castings, is called twistlock handling operation. As you can see on the bottom left picture, you see that a manual twistlock handling operation has been done. Even at the highest automated terminals, the process is still performed manually. But with the latest advancements in technologies and technological updates, there are manufacturers who have converted this manual twistlock handling operation into automated twistlock handling operation. And you can see a platform from Kalp GmbH, which is performing the same task of attaching and removing the twistlocks from the container corner castings, and that is fully automated. Jumping to the next slide is the methodology. So the methodology is very systematic. It starts with requirement analysis. Since we are working with Eurogate container terminals, so we are trying to understand the terminal processes. Then we did a very in-depth study of the available automated twistlock handling systems which are present globally, and we tried to classify them based on certain parameters. Then the data which we receive from container terminal Wilhelmshaven, we try to understand them, and based on that, we develop the simulation models. The simulation models are the ship-to-shore crane, where we are developing both the single trolley crane and double trolley crane. Then the ATH technologies, which is actually the result of the classification, what we have done for all the ATH systems that we found globally. And that I'm going to explain in the latest slide. Then, since we want to consider all the automated terminal operating concepts and with a focus of studying specifically the ATH technologies, we tried to consider all the type of horizontal transport, that is AGVs, automated terminal tractors, automated shuttle and straddle carriers. And the last but not the least is the road networks and the traffic modules. Now, the next part is the scenario development. We have considered 4 basis scenarios, which again, I'm going to explain you into the next slide. But based on the experimentation on all the four scenarios, we have developed some results, and with the experts, we're gonna validate the models. After model validation, we're gonna go to the conclusion. We're gonna develop the results and some very interesting recommendations how these ATH technologies can be deployed in an automated terminal environment. This brings to me the next slide is the classification of ATH systems. So we have studied a good number of ATH systems, and we have identified that there are basically four type of technologies on which the ATH systems can be classified. Starting from the first top left corner is the ATH system with robotic arms, which says that the robotic arm is capable of removing two twist locks or more than two twist locks. Another one is the ATH system without robotic arms, which means that the system has some mechanical joints, linkages, fixtures, which are responsible to remove the twist locks at one time, all the twist locks. Then one of its kind is the mobile robot systems, which are capable of removing the twist locks one per unit. Then the last ATH system is the drive-through system, which is basically more similar to the pinning stations. And irrespective of the type of technology used in it, that is, could be a mobile robot, could be a robotic arm, or could be a fixed or linkage system. But this is the last ATH technology that we have identified. And we're going to study all these ATH technologies into the simulation environment. Coming to the next slide is the scenario definitions. So as I said, we have identified four scenarios. Starting from the top left corner is the first scenario on crane ATH operations. In this scenario, we are placing the STS, placing the ATH systems on the crane. And in this scenario, we are considering both the single trolley and double trolley cranes, along with all the different types of horizontal transports. In the second scenario, which is off-crane ATH operations, in this, the ATH systems will be placed below the crane, that it could be into the portal, both onto the land side crane leg and water side crane leg, or it could be onto the back reach. And all the different type of horizontal transports will be tested in this scenario. This third scenario is novel, and it's one of its kind, which is basically dedicated ATH operation zone. One can understand that a specific area will be defined in the terminal premises, which will be targeted only for ATH operations. And at this area, ATH system of a similar kind will be placed there, and the horizontal transport will receive the container from the crane's key wall and then go to this area, perform the twist lock handling operations, and then it will come either to the crane quay wall area, or it will directly go to the block storage area. The scenario 4 is the drive-through ATH operation, which is basically coming from the fourth ATH technology, what we have classified. And in this scenario, we are trying to understand how many drive-through systems will be responsible for fulfilling the task for either for one crane or more than one crane, or where it should be placed strategically so that the best output can be achieved. This brings me to the last slide of my presentation. What can be expected by the end of this project? So we're going to develop the simulation models, which will be based on automated terminal concepts with a special focus on defined ATH technologies. Then there is an in-depth study of all the ATH systems which were present globally, and we classified them based on the type of technology used, based on the application area, based on how they are handling the magazines, or how they are handling the twist locks when removed, or before attaching to the container, how they are powered, and so different factors. Then when we are studying different ATH technologies, we also try to identify what type of risks are associated with the ATH system for its integration into the existing automated terminal. Then during the simulation studies, we'll also try to identify or to look into deeply how is the productivity affected, how is the process affected, and what would be the expected financial benefits. And the last, we come to the development of recommendations, which is a very good core part of the project, where we are suggesting the readers to analyze different ATH technologies and to understand how better they can be deployed into a terminal environment so that the technologies could be best utilized and better integrated into the system. So this brings me to the end of my presentation. So I'm happy to answer some questions. Thank you.
Excellent. Thank you very much, Rashid, for that interesting presentation. Thank you. So now we have time for questions. Please feel free to unmute your mics or write the questions into the chat. Actually, I have one question, Rashid, for you.
Yeah.
So during your research, how many distinct types of ATS systems did you identify globally?
Okay. We tried to identify as much as the possible ATS systems which are present globally. We just not looked into European market or just to American market. We looked over the Chinese market as well. And we found around 11 to 12 different ATH systems present there in the market, either being researched or are being tested onto the terminal environment.
All right. And what was the reasoning behind categorizing them into those 4 specific groups that you showed in the presentation?
Yeah. When we were doing the classification part of all the ATH systems, we identified that most of the systems can be identified only on the basis of these 4 technologies, like with robot arms, without robot arms, independent units, and so. So that's why it was just understanding from the classification that they were the best could be classified into these 4 technologies.
Who do you think these results of your study should be beneficial to, and how?
Mm-hmm. I think the results of the study would be best beneficial with the terminal operators as well as the manufacturers of these systems, because the recommendation and the analysis what we are doing with the technology, it's not just focusing on any specific system or any specific manufacturer. So for one technology, there could be more than one system providers or manufacturers. So when they read this study, there's a possibility for both the port operator as well as the manufacturer to understand how best this type of a technology could be better deployed into the automated terminal environment. And during with the results, one can analyze that which technology should be choose based on their operation.
We have a question in the chat. So how many systems have a track record in real operation already? Are there data available?
Based on our study, it has been seen that there are some systems which are already deployed onto the terminal environment, but they are not working in full capacity. There has been a platform from Carl GmbH which was earlier tested. Then there is one platform at Shindao New Queen 1 container terminal where they are testing, and even at the Tianjin port, they are testing this automated handling system, which is the drive-through system. And regarding the data is available, but it's not available publicly. So we are communicating with most of the automated Twistlock handling manufacturers and trying to understand how their system performs so that we can simulate it into the simulation environment in the best possible way.
All right, thank you. And we have another question in the chat.
Mm-hmm.
How many systems have been working on the terminal in real operation, and which is the most advanced system you have encountered?
Yeah. I see that there are a couple of systems which are working, as I said, onto the real environment, but as not in their full capacity. And to identify which would be the advanced system, that would be a tricky question, because when we'll be ending to the end of when we will be into the end of the study, we wouldn't be saying that this system is advanced or which one is not. Rather, we would be saying that the technology could be done advanced, or is like there's a scope of further advancements. But yeah, it's hard to say that which system would be highly advanced.
All right, then thank you very much, Rashid, again for this nice presentation.
Thank you.
Yeah, if anyone thinks of questions later, please feel free to reach out to Rashid via email. Finally, to conclude today's session, I'd like to give a quick preview for the next week's MIU. We have another very interesting talk coming up next week. My colleague, Dr. Valeria Bartsch, will be presenting on Positionierung mit dem Erdmagnetenfeld in der maritimen Umgebung, or in English, positioning with the Earth's magnetic field in maritime environments. This is another interesting project exploring the use of the Earth's magnetic field for navigation and positioning in maritime environments, without using GPS, or like this can be as a backup to GPS. See you next week or on our next iteration, and I wish you a nice weekend. Thank you for joining us today, and goodbye.